All right, so number 9 says cosecant of pi. So we know that cosecant is just taking the sine answer and flipping it. So that means that I'm going to figure out what sine pi is, and then I'm going to flip it, and that's going to give me the answer for cosecant, okay? So on my unit circle, I'm going to locate pi. So here's pi. Now the answer for sine is the y-coordinate, that's just 0. Now, to be able to flip a fraction, I have to have a number written as a fraction. So if I have a number 0, how do I take the number 0 and write it as a fraction? 0 over 1, 0 over any number is how you would take a number that's a fraction and have it become 0 as an answer. Is you'd have to have 0 on the top of the denominator and some sort of other number on the bottom of the denominator. So 0 over 1 is how we could take that and write it as a fraction. So sine of pi equals 0. If we want that as a fraction, I'm going to take it and I'm going to write it as 0 over 1. So when I flip that to write it as cosecant, then the flipped version is 1 over 0. All right? 1 divided by 0 is what? Undefined. So the answer for number 9 is undefined. So you just take your answer in terms of sine, you flip it, it's the answer for cosecant. Okay, number 14 was another one. We want cosecant of 7 pi fourths. Cosecant of 7 pi fourths. This is a good one because this is kind of a tricky one. So again, we're going to find sine of 7 pi fourths. And then we're going to flip it. So sine of 7 pi fourths, we have to locate that on our unit circle. 7 pi fourths is over here. Sine of 7 pi fourths is negative root 2 over 2. So I'm going to write that down first. This is negative root 2 over 2. And then to go back up to cosecant, I just have to flip that fraction. So when I flip that fraction, I get 2 over negative root 2. Now, is 2 over negative root 2 a proper answer? Can I leave it like that? No. So I got to fix it before I write it as the answer. So how do I fix this answer? Okay, so multiply root 2 over root 2. So the top is 2 times root 2. The bottom, we've got root 2 times root 2, so that's a root 2 squared. We do have a negative in the front. And then what happens to the bottom? Cancel, so root and the squared cancel. So we get a negative in the front. We have a 2 square root 2. On the bottom, we have a 2. We leave it just like that, or can we simplify some more? Okay. Okay, so the 2's cancel, and so our simplified answer is the negative version of square root 2. So this equals negative square root 2. Now, if I wanted to type this into my calculator to check my answer to see if I'm right, the way that I type this is I have to check my mode, make sure I'm in radians. And then to type cosecant in my calculator, it's not the inverse of sine. We know the inverse of sine undoes a fraction and gives us an angle as an answer, because we've done that worksheet, right? We've done the inverse of sine. That gives us an angle as an answer. So to do cosecant, we have to type 1 divided by sine, and then the angle, 7 pi fourths. 1 divided by sine of 7 pi fourths is actually what cosecant is. So that should be negative root 2, and it is. That's how you could check your answer in a calculator if you wanted to. Okay. All right, let's try number 17. Yeah. All right, 17 is cotangent of pi. So cotangent is very similar to tangent. I wouldn't even find tangent first to do it. So if tangent is y divided by x, then what would cotangent be? X divided by y. So with this one, you don't even have to do other work and then flip it. You can just go directly there. So cotangent is x divided by y, so we're going to locate pi on the unit circle. And we're going to do x divided by y, which would be -1 divided by 0. And -1 divided by 0 is not 0, undefined.
Oh, right, yeah, 'cause you can't divide by 0.
Yeah,
Oh.
can't divide by 0.
That's silly.
All right, we're going to look at 19. 19 says secant of 11 pi 6. Secant 11 pi over 6. Okay, so secant is just the flipped version of cos. So to find this, we're going to find cos of 11 pi over 6 first. Cos of 11 pi over 6. We locate 11 pi over 6. Cos is the x coordinate, so I'm going to write that down first. That's √3 over 2. I'm going to flip it. So that gives me 2 over √3. Is that answer proper? No. How do I fix it? Yes. √3 over √3. And what do I get? 2 √3 over 3. Perfect. And so that's my answer. Okay, and then you said 8. Sophie, is 8 the one you wanted to do?
Yeah.
Okay, and then 8. 8 says cos 3 pi halves. All right, so 3 pi halves is just down here. Cos of 3 pi halves is just the x coordinate. No, they're only going to give you unit circle ones. So cos of 3 pi halves is just 0. You were just checking to see if we were awake. Turns out we are, so we're good. All right. So if you got those worksheets done, add them to the pile. If you didn't, feel free to take it home. Yes. The trick that I remember is that sine goes with cosecant and cos goes with secant. So each s gets a c, each c gets an s, so there's no duplicates. And then cotangent and tangent sound like they go together. Yeah. So sine goes with cosecant, cos goes with secant. Yeah. Okay. All right, so let's go ahead and get out our graphing notes from last night, the graphing sine notes. We're going to finish the last example, and then today's assignment only has 9 problems. They're just 9 graphing problems, so they look just like this. I just didn't want to do too many. So I'm going to have you guys on your graphing notes. We're going to scribble out the equation that's there. I'm going to give you guys a different one. So this one right here, we're going to scribble it out because in Math 3, they don't do, this is called a horizontal shift. They don't really do that in Math 3. So I'm going to give you a different one. So we're going to scribble that equation out. And we are going to write y equals 2 sine, and then the number in front of x, we're going to do pi fourths in front of x, because I want to show you what happens if you have a coefficient of x that has a pi in it, and then a -2 on the end. So 2 sine pi fourths x, and then a -2. Okay. And I'm going to go ahead and draw my axes. So looking at this equation, can you tell what the amplitude is? 2. So that means instead of sine bouncing back and forth and going up between +1 and -1, it's going to go, or not, in this one it has a vertical shift. It goes down too. So instead of from the midline going up a unit of 1 and down a unit of 1, it's going to go up a unit of 2 units and down 2 units. So we know that from the middle of the graph it is stretched by 2. All right, what about the period of the graph? So normal period of the graph is 2 pi. How do we find the period of this graph? Might have to look at the previous example problems. I don't remember when it is. You'll have to look at Power Schools. Yeah. There's no school Monday, so it can't be Monday. All right, so Ava, how do we find the period? Yeah, so we do 2 pi, and then we divide that by the number that's in front of x. So 2 pi divided by pi/4. And since we have something divided by a fraction, we're going to have to do keep it, change it, flip it. So we're going to keep the 2 pi the same. We're going to change this to a multiplication problem, and then we're going to flip the fraction. So for us to do this computation, what happens with the pi's? They cancel each other out. So it is 8. Yeah, I thought I heard somebody say 8, but I wasn't positive. Yeah.
But I didn't want to say it out loud.
Yeah. You didn't want to project it just in case. Yeah. So this is a unique problem because most often the period is in terms of pi because 0 to 2 pi is normal. So then having it be 4 pi or maybe pi halves or something like that is a pretty typical change to the period. This is kind of a unique problem, but it happens every so often that they put a pi in the coefficient, which would get rid of the pi in the period. So it doesn't happen often, but it happens occasionally. Okay, so let's go ahead and figure out what we want the x-axis to be now that we know that the period of the graph is 8. Remember, to graph these easily, we want the period to either be 4 boxes or 8 boxes or 12 boxes because we want to choose a number that's easy to divide in half and then divide in half again. That's how we've been graphing these visually. Is easiest to do that way. So do you guys want to have 8 be in 4 boxes, 8 be in 8 boxes, or 8 be in 12 boxes? 8 boxes, just 1 box is 1. Okay, so we can do 1, 2, 3, 4, 5, 6, 7, 8. So we know that this 2 in the front tells us we have an amplitude of 2. What does this 2 on the end tell us? It's down 2. And so that tells us that instead of the middle of the graph being right there at the x-axis, where is the middle of the graph going to be? -2. So do you guys want to go by 1s? Do you want to go by 2s? What would be smart here if the amplitude is 2? So we should go, you guys want to go 2, 4, 6, 8? You want to go like that? We could make each box equal 1. There's not necessarily a right answer. You just think about like what's going to be easy to graph. And then keep in mind that your graph, if you have your intervals different than the answer key, your graph will look different than the answer key. Does that make sense? So keep that in mind. Okay, so we can just have each box equal 1. That's fine as well. Because even if we shift it down 2, we still have space to go up 2 from that and down 2 from that. So we can have our midline right there in the middle and still have an amplitude of 2, amplitude of 2. So it'll still fit. So I'm going to go ahead and trace my midline right in here. There's my midline. And how do sine graphs usually work? How do we start graphing them? Okay, so put a point at the beginning, put a point at the very end. So we got a point at 0 and 8. Where else do we put a point? At 4, right in the middle. Okay. And then what do we do? Yeah, so between the first 2 points, should I go up or should I go down? Up, because this is a positive graph. So normal sine curves go up first, then they go down, okay? So we're going to go up. Now, a normal sine curve would only go up 1. What are we going to do because we have an amplitude of 2? We're going to go up 2. So between the first 2, I'm going to go up 2. Okay? What am I going to do between the second 2? Down 2. Okay? And then I'm going to take that pattern, I'm going to do it again. So I'm going to start here, I'm going to end 8 boxes over. Then I've got the middle. Between the first 2 boxes, I'm going to go up 2. Between the second 2 boxes, I'm going to go down 2. And we make sure that we've got like a U shape kind of right here, upside down U shape, U shape, U shape, U shape. So these graphs, they don't look like Charlie Brown's hat, right? Charlie Brown's hat is a zigzag. They don't look like zigzags, they look like curves, okay? You should, when you're done with these, you should be able to trace them with your finger, and your finger should be going in a smooth wave the whole time. Your finger should never stutter, okay? The most common mistake that I see is a student at some point doing a bounce like this, where they would stutter right here because they did some sort of symmetry instead of seeing the wave continuing the pattern. Does that make sense? Where they do something that is still visually appealing, like maybe they kept the wave going like this, and it kind of visually makes sense, but your finger would stutter over this. You guys see how that works? So we want to make sure that when we're tracing this, our finger is tracing a wave, not stuttering when it gets to a certain point, okay? And then always make sure that you're drawing arrows on both sides because these curves do go on forever. All right, how do you guys feel about the sine curves? Are we okay with drawing them? So the steps to the sine curves, we draw a point at the beginning and the end. We draw a point in the middle. And then if it's not reflected, we go up between the first 2 points. We go down between the second 2 points. You go up or down depending on how much the amplitude is. So if it's regular, you go up by 1. If it's an amplitude of half, you go up half. If it's an amplitude of 2, you go up 2. If it's an amplitude of 5, you go up 5. If it's reflected, you just go down instead of up. You would just do the opposite. And then always do the pattern more than once to prove that you understand it. Does that make sense? Okay. So if you want to check your answers to make sure that you got it, the best way to check your answers, let's make sure, in this we are in terms of radians. I can tell I'm in terms of radians because I've got some pi's written on my paper. I'm going to go ahead and take my mode. I'm going to change it into radians. And then the best way to make sure that your answer is correct if you did not do the exact same intervals as the answer key is to graph it on your calculator and change your window to look like the intervals on your paper, okay? So the only intervals that I graphed were really from 0 to 16, so I'm going to change my window to be that. So let's go ahead. I'm going to type in the equation. So I've got 2 sine pi divided by 4 times x minus 2, or I can, let's go ahead and type it in maybe the way you guys would type it. 2 sine pi over 4 x minus 2. Okay, so this is what it would look like. There's your equation. And then the only part I graphed was from an x value of 0 to an x value of 16. And so I'm going to graph only that part. And then my y value I did from -4 to +4. So what I'm doing is I'm changing my window to match what I actually graphed. Does that make sense? So I'm changing my window to look like this, because then my calculator screen should look like what's on my paper. And then I'll be able to say like, oh yeah, that actually looks like what's on my paper, or no, it doesn't. Because if the answer key doesn't have the exact same intervals as me, it's going to be confusing to try to compare them, okay? So if you change your calculator screen to look the same, then it will be easier to compare, okay? So now I can go ahead and graph that, and I can see that the calculator looks the same as what's on my paper. Do you guys see how it looks the same? It's got it touching the line, it's got it starting in the same spot, it's got it touching the bottom just like mine does, it's even got it ending kind of right there in the middle. So I can feel good about my answer being right. Make sense? Okay, so I'm going to go ahead and pass out the assignment. You've got 9 problems to graph, which is doable if you understand it. If you're having a hard time graphing them, I don't want you to sit there for 20 minutes graphing one problem. I want you to come sit by me so I can graph it with you. Okay, and then we'll graph a couple, and then I want you to try. If a problem is taking you more than 4 minutes for one problem, you need to get help, okay? About 4 minutes per problem, and then we should be moving on to the next one. We shouldn't be taking, you should be able to get all 9 problems done before you leave, okay? All right.
They're like, she said 9. It's so hot though. Was it cold, Kraus? Oh, yeah.